want to talk to you about the series representation of these rational functions. And I've got the 6 kind of common ones up on the screen here that you might encounter. And I think in a previous video we talked about either 1 over 1 minus x or 1 over 1 plus x. And I showed you how we can take the simplest one, and if you've got 1 over x, you can actually do long division by 1. I'm doing that backwards, of course. Way to get off to a great start on my video. 1 divided by 1 minus x. There we go. So 1 goes into 1 one time, and we get 1 minus x. 1 minus 1 is 0, and then we subtract negative x, and we get positive x. 1 goes into x times, and you can see pretty quickly that the pattern we get is quite simple. It's just the powers of x added together, so when we want to put that into series notation, we can have k from 0 to infinity of x to the k, because x to the k when k is 0 will give us the 1, and then of course x squared, x cubed. So kind of backwards from what usually happens, the 1 minus x is actually the easier one than the 1 plus x, and you can have you'll want to memorize these, and you'll have a variety of ways. You'll come up with your own way of remembering this that helps you. I think of it that when you're in the upside down, things are upside down, so the negative is simpler than the positive. But either way, let's put that here for reference. When you do the same thing with the 1 plus x, the difference you find is that every second term has a negative sign, because when you have 1 divided by 1 plus x, the 1 goes into 1 one time, but then you have a positive x here, which makes a negative x here. And so what you get is a negative here. This stays positive, get a negative here, and that's getting far too messy for my taste, so let's take those out and redraw them. A negative, a plus, negative. And it's always a negative with the x term, the x cubed term. It's just the way it works, because we're starting with a 1, and it's always the second and fourth terms and sixth terms, etc., that have the negative sign. And so that's the only 2 pattern of positive and negative signs you'll see. So although this next step has been confusing for a lot of you, at least it's the only step like it that you have to worry about, because the way we can get this alternating series of 1, negative 1, negative 1 is taking negative 1 and putting it to our power of k. It just works out nicely. Negative 1, when k is 0, anything to the power of 0 is 1, so that gives us our 1, and then negative 1 to the power of 1 gives us our first negative 1, and then you know how it works from here. Every time you take a negative and you multiply by negative 1, it just keeps alternating between positive and negative. So that's why when we have, let's write this more neatly now, that's why when we have 1 over 1 plus x, we modify this expression just slightly to put in negative 1 to the power of k to indicate the alternating plus and minus signs. So let's make a note of this up here. K from 0 to infinity, negative 1 to the k, x to the k. And then the 2 wrinkles we have to consider are what happens when the x is multiplied by something, and what happens when the whole bottom is put to a power. So I've just done 2 here for the coefficient of x, but I've put a general n for the exponent on the denominator. One thing you can do is go to Wolfram Alpha. I'm not paid by Wolfram Alpha, unfortunately, to plug their website, but I do use it pretty much every day. And it's a good exercise to do these long divisions once, just to prove to yourself that they work, but you don't need to do it more than once. And what you can do is go to Wolfram Alpha, type in 1 over 1 minus 2 to the x in brackets, so it doesn't think it's just 1 over 1. And if you scroll all the way down to the bottom, because we're in pretty specialized territory now, it will tell you the series representation. And so it will tell you, for instance, for this, you have the sum of 2 to the k, x to the k. And the other one, the 1 plus 2 to the x, is almost exactly the same. The only difference, again, is the minus 1, 2 to the k, x to the k.